Now that you've got your feet wet with all things HPC, it's a good time to clarify some of those terms we've been talking about so you can really own your HPC expert title. When it comes to HPC, nowadays we typically talk in the peta and exa range. But you should also know how these values relate to the other terms such as kilo, mega, giga, and so on. The most common terms are outlined in this table, with each row increasing by 3 orders of magnitude from the preceding one. The world of HPC is currently pushing for exascale systems, and nowadays storage usually sits in the petabyte or exabyte range for your typical mainstream HPC data center. You've probably heard the reference to a node in an HPC system. A node in an HPC system is nothing more than an independent computer system. Think of it along the lines of describing your laptop as a node or your desktop as a node. If you had a small office of 15 computers or desktops, then that office would have 15 nodes. In an HPC system, when we refer to nodes, we're describing the number of discrete or standalone computer systems that make up that HPC system. This system, which is a half-height rack that we sent to the Ghana Space Science Technology Institute in Accra, consists of several nodes linked together to form a cluster. There are 6 chassis in this picture, and each chassis consists of 4 nodes. 24. Now these are all compute nodes. But there's one very important node that we're missing in this diagram, and that is the management node. So when we include the management node, that leaves us with a total of 25 nodes for this HPC system. In a typical HPC cluster, you will find several types of nodes. A node is described by its primary role in the cluster. Like you would have different titles in a workplace or in a sports team, the titles of the nodes in a cluster will describe their role. You can expect to find such roles in a cluster like a logger node or a head node, a compute node, a management node, a storage node, and a GPU node. So at a very top level, a node is the simplest standalone computing system that you can have. A node will consist of a central processing unit and some random access memory with a motherboard to put it all together. We will go into more detail about the various components in a later chapter, but we will also talk briefly about the CPU or central processing unit for a short bit of time now. It's likely that you've heard the term core being mentioned with most computer devices, but you may not know what the difference is between a core and a node. At a very simple level, the CPU is the brain of the computer. It does all the thinking and all the actual instructions that are issued to it that we depend on for computers to do. The original CPUs were just single processing elements. They were one single chip. As time went by, engineers were able to make these chips smaller and smaller, so we could actually fit more than one chip in the same surface area. And that's when we started to create these things called cores. A single core CPU is one processing element. A dual core CPU is 2 processing elements. A quad core CPU is 4 processing elements, and so on. More advanced computers themselves can actually take more than one CPU. So you can have 2 CPUs, each with multiple cores. But when we are talking about cores, we are essentially referring to discrete processing elements that in the past you would refer to as a CPU. Nowadays, they're just smaller versions of those original CPUs. A CPU of the same type will be the same physical size, irrespective of how many CPU cores it actually has. So, a single core, 4-core, or 16-core CPU of the same type would all be the same CPU size that fits into the same CPU socket. On the left of this diagram, the node is the big box that consists of a number of CPUs, which each have a number of cores. On the right, the CPU is the little box that consists of a number of cores, which are each processing elements. In other words, a node may consist of multiple CPUs, and a CPU may consist of multiple cores. By now, we've covered some basic terminology that you'll need to be familiar with in order to navigate the rest of this course. HPC and supercomputer, for our purposes, are interchangeable. A node is a standalone compute component. and for our purposes, it will be a server system that forms part of a larger HPC cluster. A CPU is the big compute chip that can hold multiple cores, and each one of these cores is an independent processing element. Flops are a measure of performance, but they're not an indicator of performance. Just like a car's top speed tells you how fast it can go, it does not tell you how it goes fast. You will hear mention of flops quite often when talking about supercomputers. Flops is an acronym for floating point operations per second. This is kind of like a top speed measurement for HPC systems, but it's important to realize that a top speed doesn't mean much on its own. Think of a Formula One car. You'd say it's super fast, right? Well, super fast if Lewis Hamilton is driving it, but not so much if my granny is driving it. It also depends on the conditions and what it's being used for. So it's important to realize that it's not how fast it can go, but how it goes fast. Look at this picture. You have a bunch of Formula One cars, but I can guarantee that even my granny in a wheelchair rolling backwards uphill is going faster than those Formula One cars are right now. To see the flops in action, we talk about the top 500 list. And this is not just a clever name, it is a list of the current top 500 fastest supercomputers, at least in terms of their flops. And this table is revised every 6 months. On the table there are two ratings. There's the Rmax and the Rpeak. The Rmax talks about the actual achieved benchmark, and Rpeak talks about the theoretical benchmark, which you can actually calculate. Lingao, the CHPC system, achieved an Rmax of just over 1 petaflop, and that performance once placed it at number 123 in the world. But that was a few years ago, and it has now fallen out of the top 500, which is what you'd expect. In the world of HPC, you live fast and you retire young. And for comparison, the current top HPC in terms of its Rmax is supercomputer Fugaku, which achieved 415 petaflops. This table shows a few comparative flops for some mainstream devices, as well as 3 HPCs. Tianhe 2 was formerly the fastest HPC system in the world, and the current title belongs to Fugaku, which is listed at the bottom of this table. Lingao is also included for comparison to Fugaku.